In this lesson, we will study Venn diagrams and set operations. So, a little history of the Venn diagram. It was a mathematician by the name of John Venn that lived from 1834 to 1923 that invented Venn diagrams. John Venn invented the diagrams and used them to illustrate ideas in his text on symbolic logic in 1881. This is an example of a Venn diagram here. And so in a Venn diagram, a rectangle usually represents the universal set. So that's what U represents, the universal set. The items inside the rectangles may be divided into subsets of the universal set. Okay, so the subsets are usually represented by circles. So this circle here would be the subset called A. A is a subset of the universal set. Okay. Now, two sets may be represented in a Venn diagram in any of 4 different ways. I'm going to show you those 4 different ways now. If we have 2 subsets, one called set A and another set B, and each of them are subsets of the universal set, but have nothing in common, they're called disjoint. Disjoint is the word that we use to describe 2 sets that have nothing in common. So both of these sets, A and B, they're subsets of the universal set, but they have nothing in common. They are disjoint. Another way we can use Venn diagrams to show another relationship between 2 sets is when one set, let's say set A, is a subset of the other. So like in this case, set A is a subset of set B, meaning every element of set A is also an element of set B. So this is a different case where one set is a subset of the other. If both of the sets are equal, then they coincide. So all of the elements of set A are elements of set B, and the other way around as well. All the elements of set B are elements of set A. Both sets A and B are subsets of the universal set U. In this case here, we have overlapping sets, and I'd like to say that this is probably the most common or what people are most familiar with when you say Venn diagram. This is the case where you have overlapping sets. You have sets A and B. They have elements in common. Now, those elements that they have in common, we say, are here in region, we call it region 2. The elements that belong to set A but not set B are in region 1. And region 3 holds all of the elements that belong to set B but do not belong to set A. Then any element that is neither in set A nor set B but is still part of the universal set is placed in region 4. All right, now we're going to start talking about set operations. You already know about the basic operations of arithmetic, like addition, subtraction, multiplication, and division. But we also have set operations. The first one is complement. The complement of set A, symbolized A with like this apostrophe, if you will, is a set of all the elements in the universal set that are not in set A. So what I would like to do right now is to shade the complement of set A. So everything that I'm shading now are all of those elements that are in the universal set, but that are not in set A. So the area I just shaded is what the complement of A is. Let me label that. All right. So then this is the complement of A. I've labeled it right there, this entire shaded region. All right, here's our first example. Given this universal set, A, B, C, D, E, F, G, and this subset, A, C, E, the name of the subset is A, determine the complement of set A and illustrate the relationships among sets U, A, and the complement of A in a Venn diagram? Okay, first of all, the complement of set A is the set of all the elements that are in the universal set, but they're not in set A. That means the complement of set A is going to be B, D, F, and G. These are the four elements that are in the universal set that are not in set A. So now we have the complement of set A. What we'd like to do now is to draw a Venn diagram illustrating the relationships between these three sets. So let's do this. So here's our universal set. Let's label that. All right. Let me draw set A right here in the middle. Let me label that set A here. I'm hoping you're doing this with me. All right. Elements that are in set A and belong to the universal set are A, C, and E, right? And that was given. The elements that belong to the universal set but are not in set A are those elements that are the complement of A. So that would be B, D is out here, F is out here, G is out here. And again, this is the complement of set A. So that would be the Venn diagram that illustrates or shows the relationship between these three sets. Now the intersection of sets A and B, symbolized using this notation here, A intersection B, is a set containing all the elements that are common to both set A and set B. So in order for you to be an element of the intersection, you have to belong to both sets, A and B. So I just shaded for us right here what would be A intersection B. This is what we called earlier region number 2. Okay, let's consider that the universal set is the set of numbers, the natural numbers 1 through 10 inclusive. And let's set A equal the set 1, 2, 3, 8. Let B be the set 1, 3, 6, 7, 8. And C is the empty set. Determine each of the following. All right, the first thing they want us to find is A intersection B. That's kind of sloppy, but that's A intersection B. Now, by definition, this is a set, so open up a brace. And by definition, it is the intersection of A and B, which is the set of elements that are in both set A and B. All right, so the only way you make it into the A intersection B set is if you're an element of A and you're an element of B. So let's go through this. The number 1, is 1 in both sets A and B? Yes. Therefore, it makes it into the intersection. The number 2, is it in both sets? No, it's only in set A. Therefore, it doesn't make it into the intersection. 3 is in both sets, A and B. Therefore, 3 makes it into the intersection. Let's continue. 8. 8 is in both sets, so 8 makes it into the intersection. Now, that's going to be it because set A is out of elements. That's it. Over here, the only element you haven't considered is 6 and 7, but both 6 and 7 are not in set A, so we're done. This is A intersection B. All right, the next thing they want you to find is A intersection C. All right, so let's compare set A and set C. Now, you have to belong to both sets. The only thing that C has is the empty set. Now, don't forget, the empty set is a subset of set A. The empty set is a subset of every set, right? And so the only thing sets A and C have in common, therefore, is the empty set. In other words, there are no elements that are common to both sets because set C is the empty set. All right, cool. Next, let's find the complement of A intersection B. All right, now the complement of A is not given to you, so we should probably find the complement of A really quickly. All right, so let me see if I can do that up here. All right, complement of A. Now remember, the complement of A is a set of all elements that are in the universal set, but not in set A. All right, so 1 is in set A, 2 is in set A, 3 is in A, 4 is not in A. Therefore, 4 makes it into the complement of A. Let's continue. 5, 6, and 7. 5, 6, and 7, those three elements are not in A, so I'll list those. Let's continue. 8 is in A. Both 9 and 10 are elements that are in the universal set, but not in set A. So there we have it. This is the complement of A. They want us to find the intersection of this set and B. So the only way you make it into this set here is if you're in both this set, the complement of A, and B. All right, so let's go through it. Is 4 in both sets? No. How about 5? No. 6? Yes. 6 is in both sets. So 6 makes it into the intersection. Anything else? Let's see. 7. 7 is in both sets. So 7 makes it into the intersection. 9 is not in set B. 10 is not in set B. So they're not in the intersection. There's no need to even check 1 and 3 because these would be elements that are in set B but are not in set A, the complement of A rather. We did 6 and 7. 8 is in set B, but 8 is not in the complement of set A, so I believe we are done. This is the intersection of the complement of A and B. All right, one last one. They want us to find, let's see, A intersection B, but the complement thereof. Now, let's use what we found earlier. We already found A intersection B to be the set 1, 3, 8. They want us to find the complement of this set. Now, by definition, the complement is the set of all elements that belong to the universal set, but do not belong to A intersection B. That's what we want to look at. All right, so let's go to our universal set. Is the number 1 in the intersection of A and B? Yes, it is. Therefore, it's not in the complement. Is 2 in the A intersection B? No, it's not. Therefore, it belongs to the complement thereof. Open up your set, put 2 in. Let's keep going. 3 is in A intersection B, so that's not it. Both 4, 5, 6, and 7. 4, 5, 6, and 7. 4, 5, 6, and 7 are not in A intersection B, so they all make it into the complement thereof. 4, 5, 6, and 7. 8 doesn't make it into the complement because it's already in A intersection B, but both 9 and 10 are not in A intersection B, therefore they're part of our complement as well. And that completes our set. So 2, 4, 5, 6, 7, 9, and 10. Very good. All right, the union of set A and set B, symbolized with this notation, A union B, is a set containing all the elements that are members of set A or set B or of both sets. So I would like to shade for us what we understand to be A union B. All right, here we go. First of all, anything in set A makes it into the union. Anything in set B makes it into the union. Anything that belongs to both makes it into the union. So basically, A union B is the set of all the elements that are in the universal set that are in A or B, right? All right, cool deal. Now let's go to our next example. All right, we have the universal set and we have 3 subsets. All right, the first thing they want us to find is A union B. Now, remember, by definition, this is the set of all elements that are either in A or in B. So as long as you belong to either one of them, you make it into the union. All right, so let's start. Basically, this is how I do it. I put all of A in the union, all of B in the union, but do not repeat any elements. So 1 makes it into the union, 2 makes it into the union, 3 makes it into the union, 4 makes it into the union, 5 does not because 5 is in neither A nor B. 6 makes it into the union, 7 makes it into the union, and 9 makes it into the union. Now, one thing I'd like to note is although you see 1 in A, you also see 1 in B, don't list it twice. In set notation, you never repeat elements. So this is A union B. And again, this is in order from least to greatest, but please remember that order does not matter in set notation. The next set they want us to find is A union C. So same kind of idea here. Let's compare sets A and C. Oh, C is the empty set. All right, so then everything in C makes it in to the union, and everything in A makes it into the union. That's basically going to be set A then. Although you don't see the empty set included, the empty set is a subset of every set. So then this is how we would write it. Okay? All right, cool. All right, the next set they want us to find is the complement of set A union set B. All right, I don't know what the complement of A is, so let's find that really quickly. The complement of A is the set of all elements that are in the universal set, but not in A. All right, so the complement of A would be 3, 5, 7, 8, 9, 10. It's important that you find the correct set. That way we don't make a mistake here when we list out the union. Okay, we're looking at the union of this set that we just wrote, the complement of set A, and set B. Now remember, in order to make it into the union, you only need to belong to at least one of these 2 sets here. All right, so let's go for it. So 1 makes it into the union because it's in set B. 3 makes it into the union because it belongs to both sets. 5 makes it into the union because it belongs to the complement of set A. 6 makes it into the union because it belongs to set B. 7 belongs to both sets. 8 belongs to the complement of A. 9 belongs to both sets. And then 10 belongs to the complement of set A. So then this is the complement of A union B. I probably should say that better. This is the union of the complement of A and B. All right, very good. The last set they want us to find is the complement of A union B. The complement of A union B. Now let's use what we already found. We already found A union B. It's up here in red. Therefore, the complement thereof will be any elements that are in the universal set that are not listed here. So I'm going to compare the universal set to A union B. All right, so here we go. Let's see. 5. There we go. 5. 5 is an element of the universal set, but it's not in A union B. Therefore, it's in the complement of A union B. Okay, what else? 6. No, 6 is in A union B. So is 7. Okay, here we go. 8. 8 is in the universal set, but it's not in A union B. Therefore, 8 makes it into this set here. And then finally, that's it. Oh, no, one more, right? 10. 10 is in the universal set, but it's not in A union B. So then 10 makes it into the complement. So there we have it. Cool. Okay, we have a new universal set, and we have subsets A, B, and C. All right, the first thing they want us to find is this set, folks. A union B and the intersection between that set and A union C. Okay, so they want us to find the intersection of these two sets. So let's find each of these sets first and then find the intersection thereof. All right, so let's do it. So this is equal to, what is A union B? The set A union B is the set of all elements that are in A or in B. So that's going to be A, B, C, D, E, and G. This is A union B. The intersection of that set and the set A union C. All right, so that's going to be A, B, E, F, and G. Just being careful here. There. All right, so now we just want the intersection between these two sets. So only elements that are in both. That would be A, B, E, and G. This is the final answer. All right, let's go to the next one. Now they want us to find the intersection of A union B. We already found that set. And the complement of set C. All right, so let's do it. Now we already found A union B. I'm going to just copy and paste what we just found a second ago. There. This is A union B. Now it's the intersection of this set and the complement of C. Now the complement of set C will be any and all of the elements that are in the universal set but that are not in set C. So I'm going to look at the universal set now and go through and find out which of these elements are not in set C. All right? So A makes it into the complement of C. C, D, and G make it into the complement of set C. So then the intersection of these two sets will just be those elements that are in both. Sorry if this is sloppy. So then the only elements that are in both are A, C, D, and G. Basically, the complement of set C is your final answer. All right, cool deal. Only one more set they want us to find, everybody. Let me move this up. They want us to find now, to wrap this up, the intersection of the complement of A and the complement of B. Okay, I believe that the first thing we should probably do is find the complement of A. Now, if you find the complement of A, you should find it to be C, D, and F. Remember, these are the elements that are in the universal set, but not in set A. All right, better. The intersection of this set and the complement of B, which you should find to be B, F, G. So therefore, the intersection between these two sets is only F. Good job. Okay, now that we're really familiar with intersection and union, we now want to determine the number of elements in the union of two sets. So let's say there are let's say set A has 8 elements. Set A has 8 elements. Set B has 5 elements. And the intersection of the two sets has 2 elements. Okay? There's 2 in the intersection. The question would be, how many elements are in A union B? Now, this is the thing. If we count all of the elements that are in set A, and we add up all the elements that are in set B, what we're going to end up doing is counting these two elements twice. So what we could do is count all of the elements that are in set A plus all of the elements that are in set B, and then subtract the elements that are in the intersection. This is something that you will want to write down. So the number of elements that are in A union B is equal to the number of elements that are in A plus the number of elements that are in B minus the number of elements that are in their intersection. All right, check it out. The results of a survey of visitors at the Grand Canyon show that 25 speak Spanish, 14 speak French, and 4 speak both Spanish and French. How many speak Spanish or French? Okay, one thing that is very important. This word or right here means union. That's going to be important. So whenever you're dealing with a problem and it has two different sets and the word or joining them, it always means union. By the way, if this word were an and, it would mean intersection. You may want to write that down in your notes as well. Or means union, and means intersection. So let's do this. Let's let A represent all of those that speak Spanish, okay? And then let B be all those that speak French, all right? So really what they're asking you to do is to find A union B. Actually, they're asking you to find the number of people, right? The number of elements in A union B. How many, right? So they're asking you to find the number of elements in A union B. All right, cool. Let's use our little formula that we developed a minute ago. The number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersection B. Now, remember, A represents those that speak Spanish. And according to the problem, it says 25 speak Spanish. So there's 25 that speak Spanish, plus there are 14 that speak French, minus those that speak both Spanish and French. That's what A intersection B would represent. So we're going to subtract 4. So this total here is 35. So 35 is the answer. 35 people either speak Spanish or French. What that means is 35 people either speak Spanish or French or both, right? That's the definition of union, right? You are in set A or in set B, or you're in both. So 35 people either speak Spanish or French, or they could even speak both. All right, example 6. The results of a survey of customers at a McDonald's restaurant show that 28 purchased either a hamburger or French fries. 20 purchased French fries and 17 purchased both a hamburger and French fries. How many customers purchased only a hamburger? Okay, so first of all, let us assign, let's say, let A represent the set of customers who purchased a hamburger, just a hamburger. So let me write hamburger here. All right, and let me say set B is the set of customers who purchased French fries. So I'll just put fries, okay? What we need to do is to determine the number of customers that ordered hamburgers. So they're asking us to find this, right? The number of elements in set A, those that purchased only a hamburger, okay? All right, so let's start with our formula. Let me see if I can move this down a little bit. There. Our formula is the number of elements in this set is equal to the number of elements in A plus the number of elements in B minus the number of elements in their intersection, correct? Now, do we know the number of people that ordered a hamburger or French fries? Yes, we do. If we go back up to the problem here, it's right here. 28 purchased a hamburger or French fries. Remember, the word or means union. So this number is 28. This is what we're looking for, right? This is our variable or our unknown. I copy that down. Do we know how many people only ordered French fries? Yes, 20. 20 people ordered French fries minus how many people ordered a hamburger and French fries? 17. So we put 17 here. So you can see then we're basically using what we know or given in order to find what we do not know. All right, so this is 28 is equal to the number of elements in set A plus 3. So if we subtract 3 from both sides, we get the number of elements in set A is 25. So we just learned that 25 people ordered hamburgers only. Pretty cool. Okay, folks, 2 operations remain, and that is the difference of 2 sets and the Cartesian product. Let's start with the difference. All right, the difference of 2 sets A and B, symbolized A minus B, is a set of elements that belong to A but not B. All right, so given these sets here, the first thing they want us to find is the difference between sets A and B. Now remember, this is a set of all elements that are in A but not B. So B, I'm just going to go through the elements in set A, okay? B does not make it into this set here that we're considering because B belongs to set B. D as well. E is in set A, but it's not in set B, so E makes it in. Okay, let's continue. F also makes it in because F belongs to A, but not to B. So we'll add F to the set. G makes it in because G belongs to A, but not to B. So I'll add G. Anything else? H. No, not H because it belongs to B. I'm done going through the elements in set A, so I'm done. E, F, G are the elements that are in A but not in B. Okay, the next thing they want us to find, the last thing they want us to find is the difference between A and the complement of C. Now, I don't have the complement of C yet, so I'm going to go off to the side of my paper and write it. Okay, so the complement of C is the set of all the elements that are in the universal set, but they're not in C. Okay, so now I'm going to go through my universal set and list out all of the elements that I see in the universal set that are not in C. All right, so A is in the universal set, but it's not in C. So A makes it in. Oops. Okay, there we go. B, no, B is in C. C, yeah, C makes it into the complement because it's not in set C. D makes it in, not E. F makes it in, not G. H, I, J, and K. These are all of the elements that are in the complement of C. Okay, A, C, D, F, H, I, J, and K. Now, we're ready to answer the question. We want to find the difference between sets A and the complement of set C. So what I'm going to do is I'm going to go through all the elements in A and find those elements in A that are not in this set here, the complement of C. All right, so here we go. This is equal to the set. All right, here we go. B makes it in. because B is in A, but B is not in the complement of C. D is in the complement of C. E makes it in because E is in A, but it's not in the complement of C. So E makes it in. Anything else? F, no, F doesn't make it. G makes it. G is in A, but G is not in the complement of C. Anything else? H, no, H doesn't make it. Oh, okay, so I'm done at this point then. Let me erase that comma and replace it with a brace to close the set. So then this is my answer for the difference between sets A and the complement of C. All right, let's move to our last operation, which is the Cartesian product. All right, here it is. The Cartesian product of set A and set B symbolized like this, but the way you read this is A cross B. A cross B. It's a set of all possible ordered pairs of the form A comma B, where A, the first coordinate, comes from A, set A, and the second coordinate comes from set B. All right, to illustrate this, let set A be orange, banana, apple, and let set B be 1, 2. The first Cartesian product we want to find is A cross B. Okay, so we want to find all of the ordered pairs of the form. The first coordinate comes from set A. Second coordinate comes from set B. All right, this is how I do it, folks. All right, so A cross B, let me start over here. A cross B will be equal to, all right, here we go. Open up your set. The first ordered pair is going to be orange. And then what I'm going to do is I'm going to pair orange with each element in set B. So I'm going to have orange, comma, 1, and then I'll have orange, comma, 2. So those are already 2 ordered pairs in this set. Now I will pair the second element in set A, which is banana, with each of the elements in set B. So banana, comma, 1, and then banana. Sounds funny how, that was, these elements are fruits, but whatever. Banana 1 and then banana 2. And then to wrap it up, now we're at apple. So apple, comma, 1, apple, comma, 2. So these are all, I'm going to close my set. These are all of the ordered pairs that belong to A cross B. Let's find another one. Let's find another Cartesian product. What if we switch the order? What is B cross A? All right, so B cross A, remember, it's the set, ordered pairs. I'm going to start with the number 1 now. See, now the ordered pairs are of the form where the first coordinate has to come from set B. So I'm going to start with the number 1. I'm going to pair it with orange. And then, that does say orange there. And then I'll pair the number 1 with banana. And then I'll pair the number 1 with apple. So I'm done with the number 1. Now I need to move to 2 and pair 2 with orange, pair 2 with banana, sorry that this is so sloppy, and then pair 2 with apple. These are all of the ordered, close your set. These are all of the ordered pairs that belong to B cross A. Let's do one more. What if they asked us to find B cross B? Okay, so B cross B means I have the set of all ordered pairs where the first coordinate must come from set B, the second coordinate must come from set B as well. So that means I have 1, comma 1, 1, comma 2. Now I'm done with having 1 in the first coordinate. Let's put 2 in the first coordinate now. So how about 2, comma 1, and then 2, comma 2. So That is the Cartesian product B cross B. Before we wrap up this lesson, one really interesting thing is look at how many elements are in this set. 1, 2, 3, 4. And how many elements were in set B? 2. How many elements were in set B? 2. So the elements that are in the Cartesian product will be 2 times 2, which is 4. 4 elements in this Cartesian product. If you go back, let's go back really quick to our notes. How many, this is what we found for A cross B. This is what we found earlier. We found there to be 6 elements in this set, right? 1, 2, 3, 4, 5, 6. 6 ordered pairs. And look at this. How many elements are in set A? 1, 2, 3. So 3 times. How many elements are in set B? 2. And what is 3 times 2? 6, the number of elements that are in the Cartesian product. So in general, let's write a statement here. So in general, we have this statement. You might want to add that to your notes. In general, if a set A has m elements and set B has n elements, then the number of ordered pairs in A cross B will be m times n.